Welcome to G Fun Facts Online. In the grand story of energy, we have titans of technology, nuclear power plants, symbols of our quest for clean, stable energy. And then, we have an adversary as ancient as the sea itself, the jellyfish. It's a bizarre matchup, the hyper-modern against the primordial, but in a surprising twist of fate. These seemingly simple, gelatinous creatures are causing multi-million-dollar shutdowns of our most powerful machines, forcing us to rethink the very design of our energy infrastructure. This is the story of when jellyfish and nuclear power collide. To understand this conflict, you first need to know one thing about coastal nuclear power plants. They are incredibly thirsty. A reactor generates immense heat through fission. To control this heat and generate electricity efficiently, they need a constant, massive flow of cool water. That's why so many are built on the coast, drawing in millions of gallons of seawater every single minute. This is their strength, but also their Achilles heel. To protect their intricate plumbing from fish, seaweed, and other debris, these plants use a series of filters at their water intake points. First, large grates block big objects. Then finer mesh screens, often shaped like massive rotating drums, catch the smaller stuff. This system works well against most things, but jellyfish are different. They are soft, gelatinous, and they don't travel alone. They travel in colossal swarms called blooms, which can contain millions, even billions, of individuals, forming a thick, viscous wall in the water. When a power plant's pumps suck in water during a bloom, they pull in this gelatinous tide. The initial screens are quickly overwhelmed by the sheer mass. Smaller jellyfish slip through and are plastered against the finer mesh screens, creating a biological film that blocks water flow. The pressure from the pumps is so intense, it can liquefy the jellyfish into a thick gel, which seeps through the mesh and clogs the internal cooling system. As the flow of cooling water drops, safety alarms blare. Without sufficient cooling, the plant's temperature would rise to dangerous levels. To prevent this, automated safety systems trigger a reactor shutdown, a process called a scram. It's a testament to the plant's safety design, but these shutdowns, while preventing disaster, create a cascade of other problems. And this isn't just a hypothetical scenario. It's a recurring and growing problem for nuclear operators around the globe. Take the Gravelines power plant in northern France, one of the largest in Western Europe. Just recently, in 2025, it was forced to shut down 4 of its 6 reactors after a massive and unpredictable swarm of jellyfish clogged its filters. With 2 other reactors already offline for maintenance, the entire 5.4 gigawatt plant, which can power about 5 million homes, was temporarily knocked out. Or look at the Torness nuclear station in Scotland. In 2011, a dense bloom of moon jellyfish clogged its intakes, shutting down both reactors for nearly a week. The cost? About $1.5 million per day in lost revenue. A decade later, in 2021, it happened again. In Sweden, the Oskarshamn nuclear plant had to shut down its massive number 3 reactor in 2013 after it was inundated with moon jellyfish. Workers had to physically remove tons of them from the intake pipes. The list goes on and on, a truly global phenomenon. Japan's Shimane plant, Israel's Hadera plant, the Diablo Canyon plant in California, and even coal-fired plants are affected. In a dramatic 1999 event, a jellyfish swarm hit a power plant in the Philippines, causing a major blackout on the island of Luzon, home to the capital city, Manila. Between 2014 and 2023, the Hongyanhe nuclear power plant in China experienced repeated shutdowns due to jellyfish, leading to huge economic losses. So what's going on? Why are we seeing this explosion in jellyfish populations? The scientific consensus points to a perfect storm of human-caused changes in our oceans. First, climate change. Warming ocean waters accelerate the jellyfish life cycle, extend their breeding season, and allow them to expand their territory. For many species, warmer water is a green light for a population boom. Second, overfishing. We have removed vast quantities of fish from the sea. Many of these fish, like tuna, are natural predators of jellyfish. Other fish, like sardines and anchovies, compete with jellyfish for the same food source, tiny zooplankton. By removing their predators and their competition, we've rolled out the red carpet for jellyfish to take over. And it's a vicious cycle. As jellyfish numbers grow, they eat fish eggs and larvae, further suppressing fish populations and cementing their own dominance. Third, pollution. Nutrient runoff from farms and cities leads to eutrophication, which triggers blooms of algae. This creates low oxygen dead zones where most marine life can't survive. Jellyfish, however, are remarkably tolerant of these conditions, giving them yet another advantage. Fourth, coastal development. We have lined our coasts with artificial structures like docks, marinas, and oil rigs. These structures provide the perfect hard surface for the first stage of the jellyfish life cycle, the polyp. Jellyfish start as tiny, stationary polyps that attach to surfaces and asexually clone themselves, before releasing swarms of baby jellyfish into the water. We have essentially built them massive, rent-free nurseries. And finally, invasive species. Ballast water from large ships can transport jellyfish species across the globe. A jellyfish can be sucked into a tank in one ocean and released in a new one, where it may have no natural predators and can outcompete native life. The primary culprit in many of these shutdowns is the moon jellyfish, or Aurelia aurita. You can recognize it by the 4 horseshoe-shaped rings on its translucent bell. It's found all over the world, and its ability to form incredibly dense blooms makes it a nightmare for power plant operators. When a plant is forced to shut down, the consequences ripple outwards. The most obvious is the economic cost. Losing millions of dollars a day in revenue is a huge financial hit, costs that are often passed on to consumers. Then there's the issue of grid stability. Nuclear plants provide what's called baseload power, a constant, steady supply of electricity. When one of these giants suddenly goes offline, grid operators have to scramble to find a replacement, which can destabilize the entire system and, in worst-case scenarios, lead to blackouts. But perhaps the most painful irony is the environmental setback. When a clean, zero-emission nuclear plant shuts down, where does the replacement power come from? Often, it comes from firing up fossil fuel plants that burn natural gas or coal. So an event caused by an organism thriving due to climate change paradoxically leads to a surge in the very greenhouse gas emissions that are driving the problem. So what's the battle plan against this gelatinous menace? Power plant operators and scientists are fighting back on multiple fronts. Some are focused on physical solutions, like stronger, more robust screens, or installing bubble curtains. This involves pumping compressed air from pipes on the seabed to create a wall of bubbles that can deter jellyfish from approaching the intakes. Others use arrays of water jets to create currents that push the blooms away. But the most promising area of innovation is in early warning and prediction systems. If you know a bloom is coming, you have time to prepare. This is where high-tech tools come in. A system called JellyX uses satellite data, ocean models, and machine learning to forecast the formation and drift of jellyfish swarms. It analyzes sea surface temperature, currents, and chlorophyll levels to provide a risk assessment, essentially a weather forecast for jellyfish. Researchers are also using drones and AI. A system called Jellytoring uses deep learning algorithms to analyze underwater video from cameras and drones, automatically identifying jellyfish species and quantifying the threat level in real time. The recurring clash between jellyfish and nuclear power plants is more than just a quirky industrial problem. It's a clear and powerful symbol of the interconnectedness of our world and the unexpected ways the climate crisis is manifesting. A blanket of greenhouse gases warms the ocean, which fuels a population boom of an ancient organism, which then drifts on altered currents to silence a machine built to fight the very crisis that empowered it. The jellyfish are sending us a message. They are a barometer of our ocean's health. They are telling us that our world is changing in profound ways, and our critical infrastructure must adapt. The solution isn't just about building better screens. It's about tackling the root causes: climate change, overfishing, and pollution. The jellyfish remind us that our technological prowess must be matched by ecological wisdom if we hope to secure a stable and sustainable future.